In try this 3.9.2, we're going to be taking the derivatives of log functions, and in particular, natural log functions. So let me remind you what the formula is for that. If you want to take the derivative of ln x, that's the natural log function, it's just equal to 1 over x for x greater than 0. And note that if this is anything other than an x, we're also going to have to apply the chain rule just as we've done in the past. Okay, so the first one is ln, and remember, I said if you had a quantity there other than x, you have to use the chain rule. So y prime, this is problem number 1, y prime equals, remember the derivative of ln x is just 1 over x, so that's super easy. So we just do 1 over x to the 5th, but we need to multiply by the derivative of that because it's not just an x, it's a quantity, so 5x to the 4th. We had to use the chain rule. And we can simplify this. This is pretty easy to simplify. We have 5x to the 4th over x to the 5th, which just gives us 5 over x. Okay, so number 2. How is number 2 different than number 1? Well, on number 1, we had ln of x to the 5th, and on number 2, we have ln of x and that whole quantity to the 5th power. So our outside function in this case, if we're talking about composite functions again, our outside function is x to the 5th, and our inside function is ln x. So on this one, we start with the outside, remember, when you're doing chain rule. And so you bring the 5 down, you leave the inside alone, and you go to the 4th power. So you're taking the derivative of the outside function, leaving the inside function alone, and then multiplying it times the derivative of the inside function. And that happens to be 1 over x. Super easy. And problem number 3, what rule are we going to have to apply here? Well, we're going to have to apply the product rule. We have the product of two things. So y prime is going to be equal to the first term times the derivative of the second, and the derivative of the second is just 1 over x, and then plus the second term times the derivative of the first is just 2x. All right, so we're on to problem number 4, and there are actually 2 approaches to problem number 4. And so I'm going to show you one approach first, and then I'm going to use laws of logarithms to show you a different approach. So the first approach is, notice that we have the natural log, or ln, of a quantity here. And remember, if we want to take the derivative of that, we just simply take 1 over that quantity times the derivative of that quantity. And to take the derivative of that quantity, you're going to have to use the quotient rule, aren't you? And so it would take the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, all over the bottom squared. All right, so that is the answer to this problem. You could simplify it, of course, but I'm not going to go through that. The other way to do this problem is to use a law of logarithms. So I'm going to do a quick review for you. You probably learned these laws in Algebra 2, perhaps pre-calculus, but may have since forgot them. And so there are 3 laws of logarithms that I think you should know because you might use them for some of the problems in the homework or the quiz. And those laws are that if you have the log of a quantity a times b, you can simplify that to be the log of a plus the log of b. All right, so you can rewrite the problem. If you see the log of a times b, you can rewrite it as the log of a plus the log of b. Similarly, if we have the log of a divided by b, we can rewrite that as the log of a minus the log of b. And finally, if we have the log of a to the b power, you can rewrite that as b times the log of a. And so these 3 rules you might write in your notebook, and they might come in handy for some of your problems. In this case, we have y equals ln, which is just the natural log, right, of x plus 1 over x cubed plus 1. And so using this law right here, we can rewrite that as ln x plus 1 minus ln x cubed plus 1. All right? And so we can then take the derivative of each of those terms quite easily. So the derivative of ln of x minus 1 is just going to be 1 over x minus 1 times the derivative of that quantity, which just happens to be 1. And then we're subtracting the derivative of ln x cubed plus 1, which is just 1 over x cubed plus 1, times the derivative of that quantity, which is 3x squared. And so this is just 1 over x minus 1 minus 3x squared over x cubed plus 1. And it's worth noting that if we were to simplify this answer we got up top, we would get the exact same answer. So, either approach would work. In this case, it was fairly simple to do it with this first approach, but there are times when it's easier to use your laws of logarithms. All right, these last two look a little tricky, and they are, simply because they're not written, they're not natural log functions. They're actually logs with different bases. So the first step is going to be to change our base, which we did in pre-calculus. You may not recall that, but you can go back and review it, or you can just look at this formula here. We can change our base to any other base we want. We just use this formula. So I'm going to change this to the natural log so that we can take the derivative, because that's all we have, the derivative, that's the only derivative formula we have. So f of x equals, and I'm going to rewrite it as log base e of, in this case, whatever's here is our x. So we have x squared all over log base e of 3. And so I'm going to rewrite that. Log base e is just ln, isn't it? So we have ln of x squared all over ln 3. And if you plugged ln 3 in your calculator, you'd come up with a value. So it's just a constant, just like if you were to have 4 in the denominator, you could pull that out front. So I'm going to rewrite that as 1 over ln 3 times ln x squared. This will make it easier for us to see. So when we take the derivative, f prime of x, that constant stays out front, right? Because we can pull the constant out. And then we're just taking the derivative of ln x squared. So that's going to be 1 over x squared times the derivative of x squared, which is just 2x. So that's our answer. That's number 5. How about number 6? F of x equals, let's go ahead and, I'm not going to write it with log base e, I'll just write ln. So what we have is ln of x plus 2 to the x all over ln 10. And like I did on the last one, I'm going to pull the 1 over ln 10 out front because it's just a constant. And then I have ln of x plus 2 to the x. And so I can take the derivative at this point. Okay, so f prime of x equals 1 over ln 10, that's my constant. And then I take the derivative of ln of x plus 2 to the x, so it's going to be 1 over that quantity, isn't it? Times the derivative of that quantity. And when I take the derivative of this quantity, I get 1 plus ln 2 times 2 to the x. And that's that whole quantity times that last. Okay?